Welcome to Web Handling. My name is Dave Roysum. I am super excited to begin our tour on decades. In this week's show, we explore the range of geometries that are common in the web world. These geometries include web width and thickness, as well as wound roll properties such as diameter and length and weight. Where does your product sit in these ranges? Knowing where you sit in these ranges can tell you much about the challenges that you can expect. I know your time is precious, so let's get started. Web thickness may be the most familiar property in the web manufacturing and web winding world. An example of a thin material is the food wrap found in your kitchen drawer that could be 10 microns or a half mil thick. This is 1/10 of the thickness of a human hair, as we talked about in last week's show. Challenges for the thin end of the range are many and include tension control and wrinkling. Indeed, 20 years ago, I wrote a paper on just that topic entitled Thinking Thin that advises people what to expect when moving to or running thinner materials. An example on the thick end is coated cereal box board that could be 1 millimeter or 40 mils thick. Materials like this are getting close to the limit of web handling because of bending stresses in wound rolls or merely going over rollers that can damage some materials. Materials heavier than that are usually made and cut into sheets without ever being wound. Notice here that there is a 1,000-fold difference in the thickness from one end to the other end, and that covers the majority of webs. Web weights are expressed in a variety of sometimes very confusing and odd units. For example, thin Bible paper can be as light as 50 GSM, which is an abbreviation for grams per square meter in the metric system. In the US system, that might be expressed as 30 pounds per ream, where the most common ream size is 3,000 square feet, although 1,100 and 3,300 are also in use. On the heavy end, we have heavy carpet, construction materials, or rubber sheet that can be as heavy as 100 ounces per square yard, or OZY for short. Again, about 1,000-fold difference between the lightest and heaviest webs. An example of a narrow web might be 1 millimeter or 40 mil wide dental floss. Products narrower than that are called strings or wires. Narrow web challenges include tension control because the forces are so small, and path control because there is small or even negligible in-plane bending stiffness. On the wide end, we have paper machines. Prior to the 1970s, the paper industry met the demands for increasing productivity by increasing both web width and speed. However, machine widths beyond 400 inches or 10 meters wide are at the limit of what can be economically constructed because precision rollers big enough to avoid excessive deflection are currently impractical to make. As an aside, a new paper machine complex will cost the noticeable part of $1 billion. Sometimes in web handling, it is best to think of span lengths as non-dimensionalized by width. Ribbon-like materials can have L over W's of more than 100, and path control can be a nightmare. On the other hand, paper machines have L over W's of less than 1. In that case, the roller precisions, mostly in-plane roller alignment, must be at the limit of commercial alignment tooling tolerances to avoid wrinkling and other troubles. Wound roll diameter also varies enormously. At the small end, we have some styles of lollipop sticks and capacitors used for circuit boards. At the large end, we have parent rolls of paper, which can go well over 2.5 meters or 100 inches in diameter. Roll length can be less than 10 meters or 400 inches. An example here includes adhesive tape as well as toilet tissue. Roll lengths can also be quite long. The length of an average newsprint roll is 15 kilometers or 10 miles. Ribbon-like materials are often spool or traverse wound and also can be quite long. As wound roll widths and diameters vary enormously, roll weight will vary even more. At the light end, we have wound rolls weighing only grams. At the heavy end, we have parent rolls of paper that can go well over 50 tons. The most popular of the 24 Abbott apps is the Wound Roll Sizer that can calculate one value if two of the others are known. These values are thickness, length, and diameter. This is a most unusual app because inputs can become outputs and vice versa. Beware, however, that thickness is not a thing that can be uniquely defined or even measured. In-roll thickness is even more complicated because single-ply thickness is different than stack thickness, and stack thickness varies with the radius in the wound roll. How to account for this is discussed in the app and in others of my writings, such as my 2 winding books. Wow, as we've just seen, geometries can vary by 3 orders of magnitude in the wide world of webs that we live in. Take heart, however, in that web handling is as completely agnostic to geometries as it is to chemistry. By that I mean that the laws of physics are the same at any scale. So if you understand the small, you understand the big, and vice versa. I hope you enjoyed this episode in the Decades mini-series. Stay tuned for next week's show, where we will discuss the most common web handling controls of tension and nip. If you have a topic you would like to hear about, let me know in the comment section below. If you found anything interesting or useful here, please like and share and subscribe. See you next time.